Okay, hi everyone. So we're going to start. Welcome to my presentation on performance tuning. And it's performance tuning, the Spring Petclinic sample application. I don't know if any of you have seen this application. No? Well, we'll talk, yes, one person, okay. We'll talk about it at the start of the presentation, of course. So let me just start by presenting myself. So I'm Julien Dubois, I'm French, got a little accent. I hope it's gonna be okay for you. So I'm from Paris. I co-authored a book on Spring called Spring par la pratique, which is a famous book on Spring in France. So obviously you don't know it in the US. I used to work for Spring Source in France also. That was 3 or 4 years ago before the acquisition by VMware. I'm now working for iPoint Technology, which is a French-based Java specialist consultancy. And of course, you can follow me on Twitter at Julien Dubois. If you have any questions, any feedback, anything on the presentation, don't hesitate to tweet something to me. I will answer as soon as I can. I'm a big fan of Twitter. Okay, so what are the goals of this presentation? We've got 3 goals. The first one is to make a very specific application run faster. So that's the Spring Petclinic. It's not that interesting to make that application run faster because nobody's going to use it in real life. It's not a real application. It's just a base for us to start working and see how we can improve performance of a Spring application. And then we're going to see two things. First of all, what are the classic issues that we see in a web application and especially Spring web application? And secondly, we're going to see how we solve those problems, which methodology we are using, because of course on your specific application, you will have some other problems than the one we are seeing here. So it's really seeing classical problems and seeing how we solve them so you can solve also problems on your application. And it's not so much a presentation on the Spring Petclinic, because I don't think anybody wants to use that in production. So if you want more information on this presentation, it started as a series of blog posts on my company's blog. It's in English, so you can read it. I'm following here very strictly what we had done during the blog, so you can do exactly the same thing if you want to test. Everything is clearly committed on GitHub, so every step is committed. So if you want to test, you can just do exactly the same thing. You check out the step, and you check if it's working the way it's intended to work. Maybe you will have some different result because you have another hardware, you've got something different. So it's interesting to check if what I'm saying here is correct or not. And if it's not correct, please send me an email or tweet me, and we can talk about it, of course. If some people have already read the blog entries, got some new stuff since the blog entries, 2 new stuff. First of all, I switched to Java 7, so maybe it's going to have an impact on the results. And second thing, I've got this brand new MacBook Pro, which is really cool. It's got an SSD, it's got a new Core i7 really, really fast. So maybe it's going to help or not. We'll see if it has an impact on what I did during the blog post or not. And of course, we'll learn maybe something about it. Okay, so first of all, let me introduce the Spring Petclinic sample application, because that's what we are going to talk about. It's going to be very brief because nobody's going to use it anyway. So, do you all remember the Java Pet Store, Sun Java Pet Store? Anybody learn Java with it? Yeah? Yes, that's how I started too. So it was this very horrible looking application. I have no idea why they wanted to do a pet store. That's pretty strange idea. It was a very complicated application, with EGBs, entities, sessions, everything, facade. It was not really good looking in the end, and it was supposed to work on Java EE Enterprise Server. I'm really proud of this screenshot because if you look at the bottom of the screenshot, it's working on WebSphere Advanced Server. So it's supposed to be really, really good, very expensive, just for doing let's say, very simple pet store for for a small customer. So well, I was not a big fan of this application, but still we kept up this tradition in Java to do pet stores. And Spring decided to create the Spring Petclinic. So it was a pet store, not a pet clinic, which is also a sample application, which is here to help you learn how to use Spring. It's done by Michael Isvy, who was one of my former colleagues at Spring Source. He's a Spring Source France consultant. It's a very, very classical application. The goal is not to make you learn new stuff like Angular JS and REST and so on. It's mostly to make you learn how to use a normal application, normal Spring programming on the standard application. And still, for presentations like mine, it's a very good excuse to have very cute dogs everywhere. So you will see cute dogs everywhere in my presentation. I feel it's a very good idea because it wakes people up from time to time. So as soon as you fell asleep, you'll see a cute dog, and then you will wake up again. If you want more information on the Spring Petclinic, everything is on GitHub, of course. It's open source. It has evolved since my blog post, so you will have some new stuff if you go and check it out. And there's a short presentation on Speaker Deck by Michael, so with the author of the Petclinic. So the short presentation will show you a little bit more about the architecture of the application and how it's working. I will just browse quickly through the application. Let me start it. Didn't start it before. Wow. Yeah. So I'm running it with Maven. Of course, I could run it with a Tomcat normally, but just it's easier for the presentation, so I'm with Maven. Okay, so it's starting. Okay. Here we've got an embedded HSQLDB database. And just to have a quick look at the application. Okay, so here is the Petclinic, cute dogs again. And you can find owners of pets. Have a look at them, search for them. So I don't know, that's Betty. And she's got a nice pet, a hamster. And this hamster can go and visit a veterinarian. Here you've got the list of veterinarians. Very simple, CRUD style application. You can already see there might be some trouble because, so we've got a list of owners. Each owner has a list, one too many, a list of pets, and each pet has many visits. So it's several one too many in a row. Maybe this will cause some trouble. Yeah, don't have any question on this, I guess. Yeah. Let's move on. So, first step, as I said, cute dogs everywhere. We're going to have a series of 9 steps to improve the application. The first steps are mostly putting the application in a production-like state. It's going to be hard because everything is running on my laptop. So I'm going to remove the debugging logs. Oh, just hang on. As you saw, when I started the application, we have lots of logs going on. And I'm also going to remove the database, because currently it's an embedded HSQLDB database, which is not really what you would use in production. And it's going also to distort results because it's running in the same JVM as the application. So I'm going to remove all that. And of course, well, people always tell me this is not perfect because it's all runs on your machine. Even Keynote here is running on my machine. My hard drive is encrypted, so maybe that's not a good thing also. We can also talk about that. So it's not perfect, but you will see it's, let's say, enough to work on the application. I'm going to do it right now, but this presentation is about coding the application, debugging it, profiling it. I'm not going to code the easy things like here, because this is really very easy. I'll show you quickly, but I'm going to cheat, honestly. I'll show you how I'm cheating right away. I've got here my GitHub, my Git checkout. So I'm just going to check out to go to the right point for when it's too simple or not interesting enough to work on. Let's have a look just quickly at the application itself. So if I look at the code, as you can see, it's a very classical Spring application. I've got my model here. So those are my Hibernate entities. Sorry. There's something very specific about this application. You've got 3 different persistence options. You can work with JDBC, with Hibernate, or with Spring Data. At the beginning, we're using JDBC, and then we will move on to GPA and maybe Spring Data. That's interesting from a learning point of view, but nobody's going to do an application with 3 different persistent mechanisms, of course. So those are my entities. I've got some repositories. As I said, we've got 3 kinds of repositories JDBC, GPA, and Spring Data. We've got a service layer, which is very simple. And we've got a web layer with your Spring MVC controllers. And of course, after that, you've got some standard GSPs to, well, let's say, here is a welcome page, very, very classic application, nothing fancy. So first thing is I'm going to remove, the logs. So it's very easy, it's a very classical application. The log is here, so I'm going to put everything in one or arrow. And also I'm going to move the application to HSQLDB, to MySQL, sorry. So that's quite interesting here. There's a Spring XML configuration, and it's pointing here. So I'm using IntelliJ IDEA, so it's resolving for me the variable. And in fact, all the variables are here in a JDBC.properties file. So my default were with HSQLDB, and we're going to move to MySQL. So that's pretty standard stuff. And another thing that needs to be done here in the Maven pom.xml file is importing the MySQL libraries instead of the HSQLDB libraries. So I'm going to cheat on this one because it's not really interesting. So let's go straight right here. Going to kill it. I'm doing this on the console. I can do it, of course, from within IntelliJ IDEA, but I think it's easier for you to read what I'm doing like this. So let's have a look. So I switched. Now I'm using MySQL, and now I'm using also MySQL in the JDBC properties file. So that looks good. Let's move on. There's another thing that's interesting in the application, of course, is that we're using Java. So obviously, we want to have a look at the memory. I'm running it, as I said, with Maven. It's mostly because it's more easy to use during the presentation. Of course, Maven is using some memory, but not that much. We will see it when we will go profiling. We will see Maven from time to time, but not too much. The memory footprint is still very, very slow, very, very low, sorry. It's 128 megabytes for the moment. Maybe it will grow later, but at the moment it's enough. We will see why. Of course, I'm making it quite low at the beginning. We're going to have some memory issues. It's going to be easier to spot them. And well, as I say, we should not need a lot more memory. We're not using a WebSphere or JBoss or anything else. So 128 megabytes should be enough for a very simple application like this one. So memory, so you see I am doing it for real. So this is my Maven configuration. So you say I'm putting 128 megabytes. And now I can start the application again. Each time I start the application, I do a Maven clean before running. So I clean up all Tomcat repositories just in case there are some, I don't know, passivated sessions or anything. I'm not taking any risks for this presentation. Oh, sorry. That's the demo effect. Oh, sorry, I forgot. So I'm really using MySQL, as you can see, because if I didn't start it, it's not working. It was working before, so. You see, I'm not cheating too much. OK. So the application is running. If I go here, taking some time. OK, it's here again. No problem. My application is ready to get tested, so I'm going to do, of course, a stress test to see what's going on. Cute dogs again, yeah. This stress test is done with JMeter. So I often have questions about JMeter. Is it the right tool for the job? For the moment, it's the right tool. We'll see at the end of the presentation, it might not be the right tool for everything, but at the moment, the application is not really quick, so it's going to be clearly enough to stress test it. So I did a little script that simulates a real user. So this is the guy is coming to the home page. He's downloading, of course, some CSS and JavaScript, and is going to look at the veterinarians, find the owner, edit him, post something, create a new visit, is at the same time reading and writing stuff. It's important that he writes because, of course, writes are going to make some trouble in the application. There are two parameters that are interesting here. First of all, I added a fixed time counter. So that means that the user is not clicking right now. He's waiting. Well, he's still a very stressed man. He's clicking every 30, 100 milliseconds. So like, he sees the page, he clicks. So it's someone who is very nervous. But still, it's not 0 milliseconds, which is the default, and which completely messes up the application. And the other thing I'm using, which is quite interesting, is the HTTP cookie manager. So by default, this checkbox is not checked, which means that each time JMeter reuses a thread, it reuses the same cookie, which means for the application, it's the same user. If you check this box, each time you got a new cookie, so for the application, it's a new user. So if you are putting too many stuff in your HTTP session, that's going to be an issue. So I love to put this on because lots of applications don't like this. And from this test, I'm having 500 threads, so 500 users from a JMeter point of view. And each of those threads are going to run 10 times. So that means in total 5,000 users. So it's 500 concurrent users and 5,000 users in total, which is quite good number. So that's what I just. Oh, sorry. No more mic. Yeah.
That's good. On there. Check this.
1, 2. Sorry. Just give me more time for this slide. But basically, that's what I just said. 1, 2. No, still not working.
You stop going through the top. It's actually going through the. Stop going through the house. I'm not sure why. Let me get this guy a call. Because go through the mixing board just fine. You're actually recording just fine. Yeah, you're recording well. So it's just somehow stop going through the house.
Okay. Well, we can make a little pause if you want to. Do you have any questions of what I've done? It's quite simple. I just put the application in production, did a stress test. We can start the test maybe. And for the recording, we'll say it worked. Oh yeah, that's a thing that's going to be a little bit annoying during this presentation, but it's to have a clean test. If I start right away with 500 users, it's not very good for my Java application because it needs sometimes when you start up for the just-in-time compiler to recompile the classes and to optimize everything. So if you go straight with 500 users, it's not a correct way to test. So what I'm going to do is start with 20 users, very small, make the application warm up a little bit. And once the application warmed up, I'm going to kill it. If it's OK to get killed, come on. Sometimes it doesn't want to die. OK. And now I'm going back with the real thing with 500 users. Yeah. That's OK for you? So let's get started. So my threads are going up very quickly. The applications start to go to 200 and maybe 50 requests per second. Here, sorry, the total here. It's already starting to crash, sorry. It's starting to crash very quickly, in fact. So as we can see, we had a peak at, let's say, 200, 250 requests per second. And then it's slowing down, it's crashing. We've got errors. So those are HTTP errors. The server can't handle this. I don't know why for the moment. As you can see, it's going down, and in the end, it's just going to crash. So I'm going to stop JMeter because I'm not going to torture any application for no reason. Can I go on or?
Just keep going. They're working
Okay. Okay, then I'll go on without. Can you hear me or yes? Okay, no problem then. So the application in fact crashed. If I have a look at my console, oh, I got a Java heap space. Don't know if you can you see it from the back? It's a bit small. Anyway, it's not that interesting. It's just a Java heap space. Everything crashed. I'm going to try to kill it. Oh, and it doesn't want to get killed. So I'm going to do kill.9 -9. Okay, it's killed. Okay, so that was not very good. Well, not very good. I've already shown this to several other people who told me, well, I would be really happy if my application could go to 200 requests per second. So a lot of applications that don't do that well. But this one is very, very simple. We're just doing a couple of SQL requests. It's not really a complicated business application. It should do better than that. How fast can we go, in your opinion? Okay, well, we'll see. So we had 250 requests per second, lots of errors, and it quickly ends with a crash. As you can see, my slides are correct compared to what we tested. Hopefully it will be the same during the whole presentation. So first of all, I'm going to be very direct on this one. I'm going to do some profiling. Why am I starting with profiling is that I saw there was a memory problem. So if there's a memory issue, I'm going to start a profiler. It's going to tell me very quickly what the memory issue is, if there is one, or maybe there are many issues, I don't know. So the question I always get on this is, well, does profiling distort results? Is it going to show some wrong stuff? Of course, it depends on what you're doing, but the short answer for me is not a lot. Here we will run the application with a profiler. You will see it will still go to 200, 220 requests per second. It's nearly the same results as before, but now we will have a profiler that will help us understand what's going on. I have used JProfiler and Visual VM in production lots of time. In my experience, it caused less trouble than a lot of official, production monitoring tools that you have in big banks or big insurance companies. It's of course the only way to find problems and understand what's going on. So if your production guys tell you, I don't want that, it's going to crash everything. Well, it's better to be to see what's going on and being able to correct than being completely blind and having no idea of what's going on. But I really put it in production tons of time. It really works perfectly well, especially JProfiler. And of course, it's very easy to install. It's just a jar. Well, Visual VM is provided in the JDK, and a tool like JProfiler is extremely easy to install. I'm having here 3 weapons of choice. So Visual VM, it's free. It's very lightweight. It's a light profiler. It doesn't do everything, but it's free and it's on every machine which has the JDK. So that cool. Hello again. For the recording, maybe I can go back a little bit quickly.
We never have problem recording. We got it all.
Okay, perfect.
Just the PA.
Okay, perfect. Okay. So, Visual VM is free, it's very lightweight, it's included in the JDK, so that's the easiest tool to use. JProfiler is honestly the best tool I've used, but it's a little bit expensive. And Yourkit is very easy to use, very cheap, and I found it more pretty. So that's why I used it for my blog post, because the screenshots looked better. It's also an excellent tool, and it's Yourkit I'm going to use here because I want to have the same tool as in the blog post. But for what we are doing right now, the 3 tools could have done the same job. Yeah, sorry.
How about Dynatrace?
Oh, yeah, well, there's some other tools like Dynatrace or Hyperic or AppDynamics. New Relic, they're here at the conference. They can do profiling. So they probably, well, yes, for what we're doing here, they would probably do the same job. New Relic could do the same job, I'm pretty sure. It's not, well, those are more developer tools, and a tool like New Relic or AppDynamics is more a production tool. But basically, they can all do profiling of a live application.
When you say you leave these in production, you just for your profiling, or
No. For just for profiling session, no, not permanently. Well, at my clients, we have tools like HP diagnostics in production permanently. But honestly, if you want to find something interesting, well, we just launch a JProfiler. But for a short amount of time. We don't do it in a peak production hour. Oh, sorry. Let's do the profiling. Click too quickly. So, still my same application. I'm going to run it again. And I'm going to launch Yourkit. So, you can run it in two ways, either with as a Java agent or as I'm doing it here with in attachment mode. So it's seeing the JVMs that are launched. So this is, in fact, my application. I can connect to them and profile them directly on the fly. It's not as powerful as with the Java agent, but for what we are doing now, it's enough. Because we've got a very simple memory issue, in fact. So let's have a look at memory. So we can see we are using 68 megabytes of memory. And as you can remember, we've got 128 megabytes. So should be fine. I'm going to start my stress test again. So once again, I'm starting slowly, just to warm it up. Sorry. And then I'm going again with 500 users, just to be correct, not distorting results too much. OK, let's go. So as you remember, it crashed very quickly. So and we will see if we can go to 250 requests per second, as we did. Yeah. So you, sorry. Sorry, no, we didn't go till 200 requests per second. So in fact, in this case, Yourkit slowed things a little bit, but not too much. So it's crashing again. Waiting a little bit because I know what's going to happen normally. Yeah, OK. I'm shutting it down. There's no need to be too violent with the application. So let's have a look at Yourkit, what happened. I'm going to do a memory snapshot. So memory snapshot is taking everything that's in memory and calculating what's going on. And then we can have a look at what are the biggest objects in RAM, what is going on exactly in memory. And it should be quick to capture the snapshot. Maybe it's a little bit slow here because the application completely crashed. Yeah. Whoa. It had time here to dump a heap, so it's going to work. Just it's going to be a little bit slow. I'll wait for a few seconds. If it doesn't work, we'll go to the next slide and we'll come back. The time for it to work. It's hard for him. Hang on. Maybe it's going to be easier if I was thinking maybe I should have killed it quick. OK, it's working. Cool. It never failed. Honestly, I've done it tons of time. It never failed. But sometimes when there is no more heap, it's a bit hard for Yourkit to generate the snapshot. So, loading it. So as you can see, we've got some stuff taking like here half of the RAM. So there's OK, I know what happened. OK, so that's a very interesting thing with Yourkit. Yourkit saw that the application was running out of memory, and it did a snapshot itself. And I also click on snapshot, so we had two snapshots at the same time. That's why it slowed down. But it's a very intelligent tool because it's seeing that there is not enough memory, it's doing a snapshot, and it's alerting you. So that's very good. Unfortunately, two snapshots at the same time might be a little bit too much. OK. Forget about that. Trust me for what's inside this big hash map. You can see it. You can see it here also. So it's all crashed. Here we've got something called dandelion, which is taking some RAM. And if you look inside the maps, you can see it's lots of dandelion objects. So this is something we don't know about. Have you heard of this thing? Nobody. Well, I did not know about it before, and it looked. OK. Well, we've lost enough time. Just trust me in the map. It's dandelion objects. And this thing is, in fact, has anybody used data tables, jQuery data tables? Yeah. Well, it's a small tag lib that is here to help you to create cool-looking data tables with jQuery. There's many projects in Java for doing, this. Do you display tag from Mat variable? It's a rather old display tag. No, nobody? Ah, yeah. Okay, it used to be quite popular. I don't know, 5 years ago, 10 years ago. That's the old people like me used it. And it's kind of the same idea. Let's have a look at it. I'll take this one. So this is the list of veterinarians. And so we've got this tag lib, data tables, table, and it's just showing a table of veterinarian. Very simple stuff, and I don't know why, but this tag library is having a memory leak. So this is our first culprit, which is giving us some trouble. So Dalalion is a nice, well, yeah, I said bad thing about them, but it's a very nice looking library. It's very easy to create nice looking data tables with it. It's done by French people, by the way, so it's very, very cool. And as soon as I contacted them, telling them, it looks like there's a memory issue in your library, they corrected it in like a couple of hours. So now there's no more this issue, but still, well, for our specific application, we have this issue. So that's what I said at the beginning of the presentation. Here we've got some very specific issue. What's interesting is how we solve them, how the process to solve those issues. On your own application, you will have something else that causes a memory leak, probably. So it's corrected, but for the sake of this presentation, I switched to plain old jQuery. So you all know jQuery data tables. It's a JavaScript library for it's beautifying a standard HTML table and making it exactly look the same. As I lost some time, I'm going to cheat on this one also. I'm just going to show you the result of my cheating. So this is the data table with the tag library. And let's kill this. Kill. Yeah, Java IPsp. Okay. And now it's a plain old HTML table with a GSTL, very, very simple stuff. And I've got here at the beginning some jQuery to beautify it as a jQuery table. Let's just have a look at it when it's running. Let's have a look at the veterinarians, which was the page we were on. So it's looking exactly the same thing. Even the search is working. It's with JavaScript. You can sort everything. So it's a simple HTML table with jQuery on top of it. So this is solving the first memory issue. That's good, but that was rather simple error because you could see it very quickly. Let's go on. Sorry, I launched so many things. So let's start again the application. Oh, and let's profile it again. Sorry about it. Let's close snapshot, close session, connect. So I restarted the application. So I'm going to connect to it again, and I'm going to do it all over again. So let's warm it up a little bit. And we're going to have a look if we solved something or not. Is Dandelion causing a huge issue or not? So well, we're nearly we're arriving at 200 requests per second. Looks better. Still have quite a lot of errors, as you can see. Yeah, my error rate is still high, but not as high as it used to be. It was like 20 or 30%. Now I'm even at 300 requests per second, so it's kind of better. It's not perfect. Still some errors, but still it's better. So I'm already a little bit happy. Stopping it. This time it will not crash as easily as before, so I'm doing the snapshot myself. As you can see, this is also going quicker, so we really solved something. Let's have a look. Okay, so there's a neat statistic shortcut here, biggest object. What is taking memory in this application? Let's just have a look at the two first things that are taking up memory. The first one, this is the HTTP session. This is Tomcat. So we still have some stuff in the HTTP session, less than before, but still some stuff in it. And the second thing, Sonatypes are the maker of Maven. So this is Maven. We are running with Maven, Tomcat run. So this is Maven, in fact. So my only really issue with memory is this. We still have a few stuff in session which are causing some trouble. Let's have a look at this. If I take, let's say any controller, I'll take this one. If I take this controller, if we have a look at it, and we're putting some stuff in the HTTP session. You all know Spring MVC? Yeah, very excellent MVC framework. So here we are putting a pet into the HTTP session. We are retrieving the first time the user goes to the page, and then we are using it. And when someone updates a pet, for example here we are merging, the form that the user posted with what we have in the session, and then we are saving the pet. So that's very easy to use, very good idea. Only issue is that we are putting some stuff in memory. Not that much, but still some stuff in memory. And what's interesting here is that it's not really useful. Because what do we want here? We need the pet, and we need the owner of the pet. And instead of taking them from the HTTP session, if we have a look here at the request, have you already used this kind of annotation with Spring MVC? It's the new REST annotations for Spring MVC. And as you can see, we've got the owner ID and the pet ID in the path. So we can just use them and fetch the pet and the owner again, and then update them from the database. So instead of storing data in the HTTP session, I'm going to fetch data from the database all the time. Maybe that's not a good idea from performance point of view, but from a scalability point of view, it's a good idea. So we will solve each issue one after the other. First of all, I'm going to solve this. This is, I'm going to cheat again, because this one is in fact pretty big, because there was this kind of stuff everywhere in the application. So, yes.
So how do you actually go about, like, once you see in your profiler that it's using 7% of your memory?
Yeah.
How do you actually go about trying to search in your?
For this one was pretty easy because I just looked at a search for session in my Spring MVC code, and I had this add a session attribute everywhere. So I just removed, everything that concerns the HTTP session, I'm removing it. I'm pretty lucky here because in the normal application, I would have stuff like my authentication, which is in the session, and this is something I can't really remove. But this application is very simple, so that's good for me. And I can remove really everything. I can already say because we'll see at the end, I even tested it with 100,000 users, and it worked. So here we're really solving every memory issue at all. Shouldn't I have already said the end of the presentation?
Yeah. On the Yourkit screen we're looking at,
yeah.
you have like that's the 9 million instance created, that number?
Oh, yeah, no, that's the size. It's taking 7% of the memory, and it's taking 10 megabytes. It's not that much at the moment, because I clicked, I stopped it very quickly.
Okay, but how do you know that all those instances are alive?
Oh, yeah, no, so those instances might not be live, because maybe a user, used the application, and then went away. But it didn't disconnect. The session is lasting 30 minutes. Oh yeah, so that's an interesting point, because in what we're changing here is, first of all, we are cleaning up that memory all the time. But secondly, instead of having long-lived objects for nothing in the session, we're having only short-lived objects, which has a big impact on the JVM, in fact. One of the performance implication of this is that, in fact, it's going quicker because the JVM can clean up memory quickly. It's staying in the young memory instead of going to the old memory. For nothing, because this data is not really supposed to get old. The user clicks and then it's supposed to disappear. So it's also doing good things for the memory, for the JVM. So just to have a look at the code, as you can see, I added @path variable. So I took the owner ID and the pet ID. We were not taking them before. And now I'm doing what is being done at the top of the page. In fact, I'm going to take this data all the time from the database. And I've done it for several pages because that was coded like that all over the application. So that was my second culprit. There's usually a big discussion on HTTP session, because lots of people tell me, yes, HTTP session is very useful. I'm doing it a lot at my main client. We're doing prime faces with Spring Webflow, so we're putting everything in the HTTP session. This is absolutely not what I'm doing here, but those are two different use cases. If you are putting everything in the session, well, like what we were doing here before, it's easier as a developer because you don't have to fetch data again. It's better for security because you don't have to check what's going on again. It's really easier as a developer, but if you want more performance, well, going stateless is probably a better idea. So it's really depending on what your needs are. Do you need to be very productive, or do you want a very scalable application? So I went stateless on, well, that's the method I showed you. We grab more information from the REST URL, and we are fetching again the missing data every time. So it took some work because it was we had a lot of code to change in the application, but in the end, we are completely stateless. So as a result, oh, sorry, I'm not showing you the result right now. Let's test again. Maybe it's solving stuff, maybe not. Did I start the application again? No. Okay. I'm removing Yourkit because I can already tell you that's the last time we're doing some more profiling later, but not right now. Started the application. Let's warm it up a little bit. Okay. Die. Okay, let's have a look at what's going on. So at the beginning, we're only at 200, 250 requests per second. And we had lots of errors. So as you can see, it's really looking better. We're having 400. We should arrive to 500 requests per second. Still errors, but less. Remember, we had like 8 or 9%. It's only 1 or 2% now. So it's really getting better. Not perfect, but still, we're getting better. I have a nice demo effect, and we go even quicker than I expected. So that's good.
What are those errors? Are they exceptions or?
Yeah, so it's what JMeter sees as errors. It's the application server which is not responding, giving it a 500 error something. Yeah, there's an issue with the application server. That's the whole. That's what you can think by seeing this. So that's in fact the next step. That's very logical. I had exactly the same state of mind as you. So, my application server is probably wrong somewhere. Sorry. So, we managed to have 500 requests per second, which is like twice better than before. Very few errors, but still not perfect. So, the next thing is Tomcat tuning. It looks like Tomcat is not responding very well. in fact, that was the easiest step in the whole. That's the easiest step in the whole presentation. Tomcat here, well, they're just using basic Tomcat, was Tomcat 7. But by default, you know, you're using the blocking I/O connector. So I switch on to the new NIO connector, and it solved a lot of issues. You probably know about it, the blocking I/O connector, you've got a limited number of threads, and here JMeter is like, you know, coming with 500 threads. So Tomcat just cannot cope with so many users arriving. If you use an NIO connector, then Tomcat can make some threads wait and reuse them, and it's going to work much better for Tomcat. So this is, as we run from the Maven plugin, I'm going to change it in the pom.xml. If I have to look at our Tomcat, oh, sorry. There's another thing. You need to use the latest version of the Tomcat plugin, because you only have this in the latest version. Yeah, either you know it or you don't. And it's just a matter of changing here the protocol. I'm going to copy paste it because it's just horrible to type. So I'm using now the new HTTP 1.1 NIO protocol. Let's kill it, and let's run it again. Well, that's the annoying thing with performance tuning. You start all over again, lots of time. Sorry.
One question, the previous Tomcat, how many threads were configured?
Oh, it was the default. I don't know how many it was. Don't know, maybe 50. I don't know. I didn't check that. Sorry.
Okay.
It was the default number of threads. Here it's also the default number of threads. I just changed the protocol. Sorry, so it started again. So let's warm it up. And let's do it again. No. So can we do more than 500 requests per second, and can we solve the errors? Suspense. You know the demo effect? So of course it's working. We're not having any errors anymore, and we should go up to 900, 950 requests per second, taking some time to go up, but we should reach it if we wait a little bit. Yeah, you can see it, we're nearly 700 requests per second. So it's working a lot better than before. I'll let it run in the background, and we'll check at the end the results. So the results is normally 950 requests per second. We'll check this out afterwards. No more errors, so we're very, very happy. It's like 4 times quicker than before. We don't have any more errors. We're quite happy with us at the moment. What can we do better? The next thing I always do with my profiler, I'm going to take Yourkit again, is I'm going to look at logs, JVM logs. I'm just checking, okay, only 811. It was supposed to go higher. Still it's better. That's what happens when you do live demos. So I'm going to, oh, no, I don't want to exit. I want, I didn't close the Yourkit. It might be because the reason why it was a little bit slower. So I'm going to use Yourkit again. Have a look at memory, at threads, sorry, to have a look at logs. Just one little slide on logs. So logs are blocked thread. It's a thread that is being blocked because there is something it has to wait for. I call it as synchronized somewhere. Must be something that is synchronized, that is blocking threads. Of course, they are going to cause scalability problems. And we're going to see them easily. Well, depends on the logs, but we will see them normally easily with Yourkit. So if you have a look at Yourkit, I'm trying to have something you can see cleanly. So it's only waiting. You've got all your threads here in yellow. And when you get a lock, you've got something red. You've got a red dot. So I'm going to run my stress test again. Same thing, I'm warming it up. And okay. Come on, die. And now I'm running it. I'm going to switch very quickly to Yourkit. And as soon as you see red dots, call me. Oh, there's one here. Don't know why it's looking like that. Oh, they're here. Here are my threads. Red dots coming a little bit of everywhere. They're all on the right side. You see them, the red dots? So this is probably not very good. We've got some locks somewhere. Quite frankly, at the first time I saw this, I did not know why we had those red dots, because we're using Spring MVC normally, not doing anything strange, and still, we've got some locks. I'm going to stop it because it's hard to see the logs and profile at the same time. No, the computer is just going down. It's not working well anymore. So, here I've got some really nice dots. Oh. Okay, so normally, we should have a SRAM dump. And if we look at it, we should see what is red in it. Oh, sorry. It's here, it's here. Here it is. Okay, I've got something that is blocking my CPU. Oh, it's MySQL. It's command. I can see Apache command DBCP. That's my connection pool. My connection pool is locking. If you know a little bit command DBCP, it's a so very classical connection pool that's been used like for, I don't know, 10, 15 years. I've always known this thing. Command DBCP is in fact doing a lot of synchronization. Each time you take a connection, it synchronizes. It's not a very efficient connection pool. Still, it's okay for many applications. I mean, I've been using it for years, and it's still okay. But if you tune the application very easily, like what we are doing now, you're beginning to see it. If we click on the other red dots, that's like 90% of what you are seeing is this. It's common DBCP. So my next job, of course, is to remove it. I'm closing the session. I've got a little slide for that, sorry. So my first culprit is common DBCP. It's doing a lot of synchronization, and we have replaced it with Tomcat JDBC, which is a new connection pool for Tomcat. It was developed at the time by Mark Thomas, who was working at Spring Source, but it's an Apache project. It's designed for highly concurrent systems, so exactly for what we are doing. It's included in Tomcat. Well, it's an official Tomcat JDBC connection pool, by the way, so there's really no excuse for not using it. For the sake of testing here, I kept the pool size at 8, only 8 connections, because that was what we were having with common DBCP. So if we, if we change the connection pool and we add more connections, it's not really fair. So I wanted to stay fair in my comparison. So I kept the pool size at 8. We'll see later that, in fact, we have to keep the pool size quite low. We will push it a little bit at the end of the presentation. But in fact, if you make it bigger here, it's going to slow down the application. It's strange because for me, 8 is a very small number. Probably it's because everything is on the same server. And anyway, sorry, this is my cheap consulting trick for every project. Oh, your database is the problem, Mr. the customer. It's always this. Like 99% of the time, you can just say this to the customer without looking at the problem. It's always the database. So I've removed common DBCP. Oh, I forgot to show you this. And if you want to have a look at my slides, I've put the code here. And if you click on it, you go to GitHub, and you've got the diff of my commit. So you really see what I'm doing. Should have said it at the beginning. So as you can see, I removed common DBCP, and I put instead Tomcat JDBC from Apache. And well, that's basically it. In the Spring configuration file, data source config.xml, I replaced basic data source from common DBCP by well, the data source from Tomcat JDBC. I'm going to go straight to this commit, and we don't have much time. I'm going to go through the other logs very quickly, because otherwise we will not have time to finish, I think. There are two other logs, which are not very easy to see. So I'm not going to, well, it's going to take 10 minutes to find them. Just trust me. Well, we can understand those logs just by looking at them. The second issue was a library called WebJar, which is a very nice idea. Anybody has used it before? It's for packaging JavaScript libraries as Maven jar files. Strange idea at the beginning, but for heavy Maven users, like many of us are, it's a good idea, because you just say, oh, I would like to have a jQuery, and it's just a Maven dependency you add, and you've got jQuery in your application. So it's a very good idea, in my opinion. Of course, you've got transitive dependencies, because it's Maven, so it's a very nice idea. There's only one issue, is that so your JavaScript libraries are in a jar file, and when you want to load a library from a jar file, there's a lock. There's a bit synchronized in it. So if lots of people are requesting lots of JavaScript and CSS files, which is normally the case for a web app, then you're going to have lots of locks all the time. And you have this lock because if you look here in my test, you see here for the JavaScript, I'm asking for jQuery, and it comes from WebJar. And this is causing the lock. Of course, if you have lots of JavaScript libraries, everything is locking all the time. This issue is very common in a Java application. In fact, I've already had it before. I'm using rich faces and prime faces, for GSF. So I'm doing exactly the same thing. I've talked with people who are using the Play framework. They have the same issue. Well, a lot of people are doing the same thing, which is rather annoying. There are two solutions, of course, to this issue. The first one is to have some kind of proxy server, something on top of, before your application is going to cache all those static files, which is a very classical solution. And the other solution, of course, is to use something else and not use WebJars anymore. Here, I've done something very simple. Well, you'll see it in my test. So here, I'm having jQuery through WebJar, and here I've got another step which is deactivated for the moment. And here, as you can see, I'm reading it straight from the file system. So I'm reading the same file, but not the same way. And this is removing the lock, in fact. I'm going to change my test right away. So now I'm going to look at my JavaScript file directly from the file system, and I'm going to disable the one going through WebJar. So I'm doing the same test, but not requesting the file the same way. By the way, in JavaScript, there's let's say a Maven equivalent called Bower. So I don't know if it's such a good idea to always use Maven for everything. Maybe you should have the right tool for every different job. So personally, if it was me, I would have used another tool than WebJar for this application. But still, that's a good idea and a neat solution to a complex problem. And there's a third culprit. So you can see it if you are very, very careful with JProfiler. There was, in fact, I did not know it before. In the source code, if you have a look at it, there's an aspect here. And this aspect is here to monitor performance of the application. This is, by the way, it's exposed as a JMX bin. So it's at the same time a Spring bin, an aspect, and a JMX managed bin. So that's, well, very good idea. But the only issue is you've got a small synchronized here. You see it? If you profile the application and are very, very cautious, you can see it. But it's a very small issue in the application. So I've removed everything. And I'm ready to run again and see if we have improved or not the application. Come on, die. Okay, warming it up a little bit. And come on. It will die, don't worry. Okay. We don't have much time left, so I'm going to move on. We will see the results, well, if I'm saying something right or not. We should go past the 10,000 requests per second, which is very good, I mean, from a symbolic point of view. But the performance increase is not that big, only 10% from what we had before. If we had done those, removing those logs later, we would have an even bigger performance increase. But at the moment, the application is not that quick, in fact. Let's have a look at the results. It's going. It's not. No, it's going up. Okay. If we wait, we should go to 1,000. Yes, it's still going up. Okay. So, next thing, as you remember, the application had 3 persistence layers. We had JDBC, GPA, and Spring Data GPA. And we were using JDBC from the start. So many people will say, okay, JDBC is more performant because you have more control on what's going on. But, well, let's test it. It's very easy on this application to test, so why not test it? So, so that's not as good as I expected, but still it's quite good, 841. So, are you all familiar with Spring profiles? No? No, in Spring you can have profiles where you can change which beans are going to be activated or not in your application. And here we've got in the web.xml file, we've got a profile which by default is JDBC, and I can change it to GPA. And now, instead of using those beans, the JDBC beans, I'm going to use the GPA beans. Well, I'm going to do it very easily. I'm just going to start it again and have a look. I've just switched it to GPA. Let's have a look if it does something good or not. So, warm it up. Red. So, whoa, got a little bug. Okay. So the application is still not crashing, still good, but it's a little bit slower than it used to be. And there's something, I don't know if you see it, it's slowing down, and it was at 450, it's slowing down to 400, and it's coming back. It's a bit strange. You see? 405 now, very strange. So, turning down. Oh, sorry, I already said what's on this slide. So I switched the profile to GPA. The application, in fact, is a lot slower than I expected in my slide. But we could saw it with JMeter. The application has a peak and slowing down, and then starting again. It's very strange. It's a JC issue. If you look at Yourkit or if you use if you just look at the memory of your JVM, you will see it's a JC issue. We don't have enough memory now. Why don't we have enough memory? The issue is GPA. Well, that's the only thing we changed, by the way. So of course, it's GPA. With GPA, you are using more memory in general for PAMGen, for using your entities. So you are just using more memory than JDBC. So I boost the application memory. That's the only solution we can have here. I doubled it. I did it quite simply. So let's do it again with enough memory for our friend GPA. So more memory. Let's go on again. Yeah, starting up. Okay. So, works better with more memory, definitely. So the application should go to, I would say, 800 requests per second, but still I will have the same demo effect. It should be nearly as quick as JDBC, but not as quick, normally. Wow.
What happens if you run with this memory configuration?
With JDBC, doesn't do much. Doesn't do much. No, it doesn't do much. But that's a very interesting point, because I'm changing something.
Yeah.
Yeah, of course.
At what point do you start looking at changing the method of charge function, the parallel current?
The different, at the end we'll test with the new G1 garbage collector. Is that what you mean? Yeah, we'll try some other garbage collector mechanism. Oh, by the way, no, it's so quick that we're reaching the end of the test. No, we had 500 users going 10 times. At the beginning, we were never arriving at the end of the test. We are arriving now quite quickly at the end of the test. So it's 1058, so it's quite good, no errors. So quite happy with JDBC without doing anything, which is, let's say, magical. Oh yeah, sorry, that's exactly what I expected, 1103. But that's different, by the way, from my blog entries. With my blog entries, I did not increase the memory. I was staying with 128. So it looks like JDK7 is having an impact, probably the garbage collector. So it's not very important, but still, there's an impact with JDK7. And there's a second problem we didn't talk about. Hang on. I'm going to start it again and launch another tool we have not used yet. It's a MySQL Workbench, because we haven't looked at the SQL request. It's going to be time. When you're doing performance tuning, usually SQL requests are an important part of the tuning. So let's have a look at my server, putting it a little bit bigger. So here you have the queries per second, which is, of course, a very important indicator. And I'm going to run it again. And we'll have a look at this matrix. So it's going up, 5,000 requests per second, 10,000 requests per second. And it should peak at 15,000 normally. Yeah, 15,000 requests per second. So that means 15,000 SQL requests per second, which is a lot. Here, it's good for our applications that everything is on the same server. If I was in a real production environment with network latency and so on, my results would be a lot worse. Here it's, in fact, having everything on the same box is probably making the application look better than it is in real life. So, it's not very. It's very, very small. Oh, yeah, sorry, I didn't say it before. Well, it's if you look at my blog post, you have the script I use to fill up the database, but it's very, very small, in fact. Everything should be in memory. Well, what's slow here is you are doing lots of requests. It's not really the size of the data. Well, yeah. We'll talk about it again.
You mentioned previously that if you increase the connection pool size, it does performance.
Yes, in fact, yeah.
Why would that be?
I guess we are doing a lot of writes, and at some point the database just can't cope writing at the same time. All those concurrent writes at the same time. But it's hard to say. I've got an SSD. It's encrypted also, so I've seen that this is causing a lot of locks. So, well, the database is clearly an issue. But my main issue is mostly why do we have 15,000 requests? It's really a lot. And this is something I haven't told you before because we don't have time to do everything. But with JDBC, in fact, we have twice as many requests. We have 30,000 requests with JDBC. So that's really a lot. So with GPA, we've got half as many requests, it's a little bit quicker, but not really quicker. And so my question is, well, why isn't it, like, let's say, twice as quick, since we have half as many requests? So that's something very strange going on with GPA.
If JPA is making half as many requests, is this really an apples-to-apples comparison? I mean,
No. Yeah, that's a good question. No, that's not an apple-to-apple comparison. Well, it's supposed to be the same repository with GPA and JDBC, but we can already see that GPA is a little bit more clever than JDBC, and it's fetching more data each time. JDBC is not doing the same request as sorry, GPA is not doing the same request as JDBC. And well, we're going to see one of them straight away, because as you can see, there's one request that is very slow. So if you use, I've only got 20 minutes left, so I'm going a little bit quicker for that. If you look at MySQL Workbench, you will see which request is slow, and you can see there's a huge request, very, very slow. And what's happening is that you all know what lazy loading is with Hibernate or with GPA. Yeah, you know, by default, your collections are lazy loaded. And in fact, here, if you look at the code, there is one collection here. So it's my pet is doing visits to the veterinarian, and this is eagerly loaded. With it is, well, the idea if you want a pet, you want to know if he came to see the vet or not. But in fact, this is being used elsewhere in the code. If you go to the application, sorry, got it here. If you go to the application here, find owners. So I've got owners, okay, cool. But for this owner, I'm fetching his pet. So if I'm fetching his pet, I'm fetching his visits. And if I have a look at it, this guy had 10 visits to the vet. So this is just exploding. And each time you go into this page, it's in fact quite slow. It depends on the number of pets and the number of visits to the vet that he has done. But this is just not scaling up. So the solution, of course, is to make this a lazy loaded collection, which is the default with GPA. Sorry. So I'm just coming back to the default. And this, well, takes the time. I'll do it. This is solving my first issue, of course. We are not fetching all the visits to the vet when it's not necessary. But this is causing me a lazy initialization exception. You probably all know this one. Yeah? No? Yeah. You know, when your GPA entity is in a transaction, it can fetch all the data. But as soon as you leave the transaction, it is not able anymore to fetch the data. So that's what's going to happen here. Let's go back here. So this page is working well. And when I go here, you know, I'm just going to see, it's exactly the same test that I did like 30 seconds before. And now if I go there, oh, I've got this exception. And what's happening? I've got lazy initialization exception, failed to lazily initialize the collection. And this is because here in my GSP code, I'm doing pet.visits, and it's inside the GSP. So no more transaction. GPA cannot fetch this data again. So there are several solutions to this issue. I've done it very simply here. I've used the open session view pattern. So it's only a sublet filter that is going to keep the transaction open all the time. It's not the best solution. The best solution would have been to refactor the code. But here, as it's inside the GSP, it was really a lot of trouble to change everything. For this particular issue, it's good enough. And it's very easy to implement. As time is running, let's just have a look here at the code on GitHub. So as you can see, so this is provided by Spring, the open session view filter. And I'm putting this filter here on this URL, /owners. And if you have a look here, of course, it's /owners. So as soon as I have this filter in place is going to work. The transaction will still be open. So GPA will be able to fetch that data. Of course, here now my transactions is open longer than before, so it's not perfect for performance. Sorry, let's test it. Did I coded everything? No, I didn't put, oh, okay. Time is running, I'm cheating. Lazy loading. Here it is. Okay. So we are at 1,100 requests per second. And we should go a little bit higher now, like 1,250, something like that. We'll check it afterwards, because time is running. So normally 1,165. If we have a look again with MySQL Workbench, you will see there are less requests, only 10,000. So we moved 33% of the request, which is quite good. And we have beaten the JDBC version in every part. We have more HTTP requests and less SQL requests, which is very good. Let's have a look at the end result. Yeah, going down a little bit. Yeah, it's nearly the same result as my slides. Like, I'm very happy with this result. So it's 1,156 here. Sorry. We have not talked about caching yet. And of course, that's the last thing I'm going to add. When you use GPA, one of the good ideas with GPA is that you have a second level cache for your entities. We have not used any cache at all. And for a performance tuning talk, that's important, of course. So let's add some cache. To put it quickly, I've just put the Hibernate add cache annotation everywhere. Owners, pets, visits, collections, like everywhere. I've been using cache as an implementation. You've got other implementations like Infinispan, but cache is very good for me. And well, let's just have a quick look at the code. I'm going to cheat again, but this is just to show you the code. Here it is. So this is the same class as before. It's the pets. As you can see now, we've got this cache annotation from Hibernate. And you remember my lazy loaded pet visits. Well, now this it is still lazy loaded, but there's a cache on it. So it's not really a big deal if I lazy load it, because it's in the cache anyway. So this is going to be a big help. Yeah.
What is the ratio between the reads and the writes?
Oh, what is the ratio between the reads and the writes? I have not looked at it.
You have more writes than caching will.
Yes, yes. There are some writes. So well, that's in purpose. If you have a look at my script, you know, I am changing the owner, for example. I'm doing new visits. I'm doing it on purpose to invalidate the cache. Because, of course, otherwise, yes, it's too easy. No. So I have put the Hibernate cache everywhere. And also, I have used the new Spring caching abstraction. Has anybody used it before? Yeah? Yeah. It's quite popular. It's very easy to use. Here, I could have done the same thing with the GPA query cache. Well, just have a look at. Let's just have a look at the code. Hang on, it's a GPA owner repository which is causing trouble. So there are several queries which are causing trouble, but this one in particular, if you use MySQL Workbench, you will see it. This one is starting to cause trouble. Well, before being at this point in time, we did not see it because there were so many other troubles. You were not seeing this issue. But now that we have tuned the application, we are beginning to see this kind of issues. So this is select with a like, and it's a little bit slow, in fact. It's this page in the application. Oh, I killed it. Sorry. Let's run it again. It's a page in the application where you look for the owner of the pet. So you are looking for the guy, and that's a like. Come on. Oh, if you go to find owner, this is the like clause. Well, there's nobody with the F. Doesn't matter. So I could have done it with a second, with a Hibernate query cache. It's exactly the same thing. I have used Spring because it was already configured in the application. There are also some more interesting things with Spring is that you can do a higher level cache. Here, if you have a look at my code, I'm putting the cache here on the repository. I could have put it higher on the service layer and not even start a transaction, just return the cache to result straight away. But well, it's the same idea. I'm not going to run it right now. Or I run it quickly behind the scenes, so you trust me, because otherwise.
Do you need additional configuration required to use the Spring caching?
Is there additional conditions for using Spring Cache?
No, I mean additional configuration.
Oh, no, sorry. Everything is in, that's a good question. Everything is configured in ehcache. So I've got a ehcache.xml file, and that's where I put my Hibernate cache, and my Spring cache is using it normally. Where is it? Yeah, owner by last name. This is the one I was using. So yes, that's an ehcache. Well, you need to configure your cache implementation to use it correctly. Sorry. Where is it? It's here. Don't remember, did I put 20? Yeah. So let's warm it up a little bit. Stop. Come on. Okay, it's killed. And now, so I did, yeah. Let's do the real test. So, this is well, we're starting to see the end of our test. We should arrive to 1,240 requests per second without any HTTP error. So that's 5 times as better as at the beginning, without any errors at all. So it's a lot better. But the question is, can we do even better than that?
So, one
yeah.
question, how do you know here that you don't reach 3,000 requests per second?
Hang on. Because we're going to do some extreme testing. Because the issue here,
No, without doing any error, here we see just a number, but how do you know which is the maximum?
yeah, no, that's exactly my point. Here we have not reached the maximum. Here, if we have a look at it, in fact, JMeter is not doing much. You see, the average is very low. Everything is very, very low. In fact, now our issue is not the application anymore. It's JMeter. JMeter is not pushing the application to its limit. In fact, the application is more performant than what JMeter can do. We have reached the limits of JMeter. So we are going to hack JMeter a little bit. There's not much solution to this. If we had more threads, JMeter has trouble if you have more than, well, I have read more than 300 threads. Here I've got 500. If you put 1,000 threads, it's not doing a big difference because, in fact, JMeter is slowing down. So adding more threads is not stressing up the application more. Just JMeter does not cope with so many threads. So I have tricked it a little bit. I removed the counter. So I said at the beginning you should not do it. But this is, in fact, causing some latency. So I removed completely. I've decreased the ramp-up period because here we're taking 10 seconds to get started. I'm starting even quicker. And but I'm not going to do it here because otherwise graphically you will not see everything. But what's slowing down JMeter is this report. Because calculating this with all the averages and so on, it takes some time from JMeter. And it's calculating this all the time. So this is really slowing down the whole JMeter thing. So if you're doing it yourself, you can just disable it, tell JMeter to dump the results in a file, and then open up the file later. So that's the only way to do it. Here, of course, I'm going to keep this because otherwise we will not see anything. So it's going to be slower than we can expect it to go. If I read, I didn't warm it up, but it doesn't matter. Should have warmed it up? Well, okay. 2,500 requests per second, already finished, so good. Yeah, now the test is going very, very quick. You remember at the beginning, we could not even start it, and now it's finished in, I don't know, a few seconds. So we achieved 3,000 requests per second. That's with removing the report, which is slowing things down. Memory is very stable. So I tested it with 100,000 user sessions, and it worked without any issue. I didn't do it here, but a good thing here now is to increase the JDBC pool size. Now it's helping. It was not helping before, now it's helping. A bit of a strange result, but you should not put it too big. If you put it to 40, it decreases. It's very, very interesting just to test with just changing this number. I'm going quick because I only got 4 minutes left. I've got some final notes on what we saw. So I tested with the new J1 garbage collector. And in fact, the results were slower, which is a surprising result. Talking with some of my colleagues, they told me the J1 needs a lot more RAM. So if you put 500 megabytes of RAM, maybe it's going to be quicker. But honestly, it doesn't do any miracle on this application. There's also another question we had at the beginning. Does my new MacBook Pro help? Is it good to have a SSD and new Core i7 CPU? Well, not that much, because if you remember the beginning of the presentation, we had memory issues. Well, the SSD and CPU are not going to solve that. We had HTTP errors. The CPU and SSD are not going to help. The only difference we have is at the end, my end results are 10 to 20% better than what they used to be with my previous MacBook. So it's better, but it's not incredibly better. And it's only better once you have tuned the application. So on this particular application, if your application is too slow, showing new hardware, bigger hardware is not going to help, which is a good lesson because it's more, if you are a good coder, then you can have a better application and not someone with lots of money who's buying more hardware. So that's good for coders. It's good for us. Just to sum it up, so we had 8 steps in what we just saw. We started with the first 2 steps, is just having the application ready for production and creating a test. We started quite quickly to do profiling and removed the memory issues. We tuned up the application server. We removed the memory locks. We played with the database access, so JDBC versus GPA. And the most important things for me are using lazy loading and cache. That means using GPA correctly. If you're using GPA, you need to take a lot of time to think about your model and how you design it and how you tune it. GPA is a very complex beast. And we have like 1 minute for questions and answers. If you have some late questions, don't hesitate to send me a tweet. I will gladly answer every tweet I receive. Well, that's it. Do you have any questions?
For Spring Data?
Oh, sorry, yes, Spring Data. I didn't talk about Spring Data. I also did some tests with Spring Data. It's a bit, it's not a good test because they've coded in a different way with a cache on one method. So, but excepted this cache, it's exactly the same thing than GPA. The only thing, if you look at the code, that's what's good with this application. You can just compare the 2 versions, doing exactly the same thing. And with Spring Data GPA, it's just a lot smaller, lot smaller. So it's really developer productivity.
The same as GPA, right?
Sorry?
The performance.
Oh yes, it's not adding really much. Maybe taking a little bit more memory, but you don't see it. It's really the same thing in the end, but with a lot more developer productivity. It's a good thing in this application to have a look if you have a look here at the two repositories you have got here, you can take GPR owner repository. So this one is done with GPR, and you take maybe this one is better, the pet. So here you've got this code, and if you go to Spring Data, you can only get an interface. And it's like, there's no code at all anymore. So it's pretty easy to see that if you're a developer and use Spring Data GPR, you're just going to be much more productive.
So can we add a cacheable to the JPA too, to the Spring JPA?
Oh, yes, but once again, I know I did it like this in the presentation, but I would, in fact, add the add cacheable here, on the service layer. If you do it on the service layer, so find owner by name, it's here. If you add it here, so it's going to work for every persistence mechanism, but it's going to work also, at a higher level. So you will have less calls to the underlying beans. So it's going to be even quicker if you put it here.
But I mean, the service layer can have multiple beans, and it could have some form of a business logic in it. Then how would it?
Yes, it depends. This service layer is not a real service layer because there is no business logic. That's why you see it's a very, very simple application. Of course. Do you have any more questions? No? When do we go eating? Okay, well, thank you very much. And really don't hesitate to come and talk with me. Thank you.